Hello, welcome back. Today we are continue with 4.4 intermolecular force. Inter has the meaning of in between. Okay, so in bahasa intermolecular force is daya tarikan antara molekul. Okay, so basically for this topic, I will going to make it 5 to 6 video at where we are going to discuss what are the type of intermolecular force, and also what are the factors that will influence the strength of this intermolecular force, and then this intermolecular force we will relate with the boiling point, solubility, and also density of water. Okay, now I'm going to show you two molecules of HCl. Here is one molecule, and then here is another one molecule. So the bond between H and Cl is covalent bond, while here the dotted line here is called intermolecular attraction or intermolecular force. So in between intermolecular force and the covalent bond is stronger than intermolecular force. Another term for covalent bond, which is more general, we can know it as intramolecular force. So what's the difference intra with inter? Inter just now we went through is means in between. So intra is inside, is considered like inside the molecule. So again, we do the very quick summary. Generally, intermolecular force is weaker than intramolecular force. Okay, so basically, again, we want to focus here the type of intermolecular force that in this chapter we are focused on the covalent compound. Okay, so there are two types of intermolecular force for covalent compound. First one is van der Waals, and then second is the hydrogen bond. However, van der Waals force can divide to two types again. One is dipole-dipole interaction, or another name we call permanent dipole. So from the word permanent means that it is fixed. Okay, and then another type of van der Waals force is called London's forces or dispersion force. So just a very quick remark only here. Compare the permanent dipole and also London forces. London forces are temporary type. Okay, later we will go in details. Okay, a quick revise again. There are two types of intermolecular force between covalent compounds. First is van der Waals forces. Second type is hydrogen bond. Under van der Waals force, there are another two types. London forces, also known as dispersion force. And the second type is the dipole-dipole forces, which also known as permanent dipole forces. Okay, so now we look at London forces first. London forces in general can be found in all molecules. Okay, so basically, let's look at the first example here. Okay, imagine there are two molecules, non-polar molecule, two non-polar molecule. How are going to know there are two non-polar molecules? Because from this diagram, we see that seems like the electrons are distributed evenly. This is what we're going to say. Average electron counts of two non-polar molecule. Okay, evenly. Okay, or in bahasa sekata. Okay, but then actually we know that the electron is not always stay at the fixed position. They are always moving. So when they're moving, and then we look at this diagram, the arrow is pointed to the left hand side, so we will get the idea. Here is partially negative, and at the right hand at right hand side here is the partially positive, and hence why here is partially negative, because most of the electrons are moving at this side, while this side also have electron, but the number of electron is less. Okay, so that's why at here they say at any instant, okay, at that moment, at certain moment, okay, pada masa certain moment, that means seketika itulah. Okay, seketika itu, the electron distribution around the molecule will likely produce a dipole moment, just like what I mentioned just now. Left hand side more electron, so that's why it will be partially negative, and right hand side less electron, so it will be partially positive. Then next one, we will say that because here is partially negative and then here is partially positive, so this one is intermolecular force, at where we can consider it as London force. So because of here is positive, and then they will induce, okay, look at here, a temporary dipole moment, okay, can induce in bahasa we can use the word mempengaruhi lah. So they will mempengaruhi molecule next to it at here, so that more electron will be attracted to this side, because positive, so here they will attract the more electron to this side lah, and then here will become partially positive. So these cases will be always happen and continue to influence or induce the next molecules. However, at the same time, the molecule is always moving. Maybe there is one moment later, more of the electron is moving at the right hand side, and then at the left hand side it will become partially positive. When here become partially positive, they will induce this side become partially negative, and then here will become partially positive. That's why we say that London forces is temporary dipole moment. It will vary depending how the electrons are moving. So during the tutorial time, I will show you a video to let you have a more clear idea about London forces. Okay, after we know the meaning of London forces, we have to know what are the factors that can affect the strength of the London forces. Reminder again, generally in London forces can be found in between all the molecules. So the strength of London forces will be depending on size and also the molecular shape. Okay, basically the larger the molecular size, the stronger the London forces. While for the shape, the linear shape means that they will have higher contact surface area, which will form stronger London forces as well. Okay, now let's look at this question. Explain why boiling point of chlorine is lower than bromine. So basically, when the question is asked about boiling point, basically means that we have to find out what are the intermolecular force. IMF is intermolecular force that can be found or exist between the molecules. So generally, these are the flow how we going to answer the questions for boiling point. First, here showing you, we need to identify the type of compound. So for example, both chlorine and bromine are covalent compound. After we notice that they are the covalent compound, so we have to check the polarity of the molecule. So the polarity of the molecule will not explain further because we already learned in 4.2. So again, basically because of chlorine and bromine, the electronegativity between two atoms in the molecule are similar. So we will consider they are nonpolar molecule. So if they are nonpolar molecule, so the intermolecular force that exists between them will be the van der Waals force, which is the type is London forces. So what are the factors that can influence the strength of London force? So previous slide we already mentioned the factor is molecular size and also molecular shape. But in between these two molecules, it is very obvious it is about molecular size lah, because chlorine and bromine have different molecular mass. Okay. Okay, let's look at the second question. Which has higher boiling point, pentane or 2,2-dimethylpropane? So basically, I just roughly show you the 3D structure for the pentane is at the left hand side here, and then the 2,2-dimethylpropane are at the right hand side here. So just a bit recall for chapter carbon compound in your SPM. From the word pentane, it is part of like pentagon, so we know that this pentane contains 5 carbon, while 2,2-dimethylpropane, so from the word propane, prop here, we know that is 3 carbon, and then methyl is 1 carbon, but we have di means we have 2 lah. So 2 times 1 carbon plus 3, so also there is 5 carbon. So basically, I will know that this compound pentane and 2,2-dimethylpropane has similar molecular size. Okay, so again, when we want to know which one has higher boiling point, we have to relate to the intermolecular force. So when we want to start to identify what is the intermolecular force, then will be better. At first, again, we have to know what are the type of compound for pentane and 2,2-dimethylpropane. They are covalent compound because both of them are, both carbon and hydrogen are nonmetals. After we know type of compound, then we need to know polarity of molecule. The electronegativity between carbon and hydrogen is very slightly different, at where we consider the bond between carbon and hydrogen are nonpolar bond. Therefore, the whole molecule for pentane and 2,2-dimethylpropane are nonpolar molecule as well. So since it is nonpolar molecule, so the type of intermolecular force is London forces, which is under the category of van der Waals force. Okay, so just now at the beginning, we already identified that both pentane and 2,2-dimethylpropane has similar molecular size. So hence in this question, if we want to determine what is the factor that will influence the boiling point, so basically will be the molecular shape. Okay, so there are 2 questions in this video, so try to answer, and then I will ask you during the tutorial time. Okay, thank you for your time, and don't forget we still have another 4 to 5 videos regarding to the chapter 4.4. Okay, see you again. Bye.